Hi everyone. Today we're going to look at a LeetCode problem, factorial trailing zeros. Given an integer n, return the number of trailing zeros in n factorial. For the first example, if the input is 3, the output should be 0. Because 3 factorial is 6 and there's no trailing zero. For the second example, if the input is 5, the output should be 1. Because 5 factorial is 120 and 120 carries no 0 at the end. For the next example, if the input is 0 and the output should be 0. Okay, so you might be thinking, if we have like say 120, why don't we just chop off or like pop off tens and count the number of zeros? Well, that sounds like a possible solution, but we probably will end up with like data overflow when we have large numbers. However, if you could just break down the factorial and look at its factors, you'll find a pattern that will help us solve the problem more efficiently. I'll prepare a few factorial sets here to help you see the concept. To count zeros, we need to deal with tens. And that's the core concept behind the problem. And we all know that 2 times 5 is 10, and 10 always carries a 0. Given this fact, we may be able to infer the number of trailing zeros by counting the number of 2s and 5s in a factorial. But if you're looking at 2s and 5s that I highlighted, you'll see that it's more efficient, closer to the answer to count 5 than to count 2. For example, like factorial 5, here I expand 4. We have 3 2s in this, and the number of 2s is more than the number of 0. But if you look at 5, we have 1 5 in this, and that's exactly what we need. If you're looking at a factorial of 10, which is like 3,600,280,800, a large number. We have 2 zeros, and if we count 2s, there will be at least 8 2s. 1, 2, 3, 4, 5, 6, 7, 8. So it doesn't really help that much. So instead of considering 2s, we should just count the number of 5s. 1 and 2. 2 5s correspond to 2 zeros here. The third example, 15 factorial, is also straightforward. It has 3 zeros, and if we expand 5, 10, and 15, and look at the right side, we have 3 5s, which is the answer. 3 zeros. So at this point, you might be thinking that we can just take our n and divide it by 5 to figure out the number of 5s that we have. Maybe you are right. If you look at those examples again, the first 3 examples, 5 divided by 5 is 1, and 10 divided by 5 is 2, and 15 divided by 5 is 3. They all seem to work so far. But what if we want to figure out the factorial of 25? 25 divided by 5, which gives us 5, but just 6 zeros at the end, and you can see here. So additional rule is that if the remainder is divisible by 5, you should continue to divide. For example, here, 25 divided by 5 is 5, which gives us the solution 5, right? So whereas the 5 is the quotient, 5 divided by 5 equals to 1, and 5 plus 1 is 6, which is corresponding to the 6 zeros here. Hopefully you have a better understanding of concept right now. Let's get to the code. Let me comment this out. Okay, all we have is a function called like trailing zeros, which takes in n as an input, and n is the factorial that we want to find the number of zeros for. Okay, so we start by initializing a counter here, and we set it to 0. Then we have a while loop, and the condition for the while loop is to check if the n is equal to 0. If it's not, we're gonna just keep executing the code inside the while loop. And here we have a variable called new n, and we need to divide that number by n by 5 every time, and then add that to our variable. Here now we have to increment it every time when we get to number 5. And still save it to the counter. Then we set n equal to new n. This is a very important step because this is gonna take care of the additional rule we just mentioned, where the solution is still like divisible by 5. This is gonna keep repeating until hitting the condition here. Okay, here. So, and at the end, we'll just return count. And let me run the code to see how we did. Okay, it's accepted, and let me submit it. Okay, great. Since we only have one while loop, this is gonna operate on all of n. In terms of space, you'll be all of 1. Thank you for watching. See you next time. Bye.